This is a 6 degree of freedom robotic arm with working inverse kinematics made in Roblox. Inverse kinematics is the process of determining the joint angles from a final desired end effector position and orientation. It is applied geometry. The position of the end effector can be moved left, right, up, down, forward, and backward, and its orientation in yaw, pitch, and roll can be controlled independently from its position. The motion overall looks very natural. It is created using hinge constraints, which can simulate a servo's behavior fairly accurately. In proper terms, it is called a revolute joint. The first 3 joints control the end effector's position, called a manipulator, and the final 3 joints control the end effector's orientation, called the wrist. Almost every robotic arm follows this design because of its ease of analysis and dexterity. Here is an image that I took from one of my university's labs. The inverse kinematics can be done by a technique called kinematic decoupling, in which the inverse kinematics problem is split up into 2 problems: position and orientation. Position inverse kinematics. The first joint rotation is about the upward axis, and the next 2 are about the sideways axis. I am not using the terms X, Y, or Z because those are all arbitrary and can change from book to book and engine to engine. This problem is very intuitive to solve. First, rotate until the arm is aligned on the same plane of the desired position that is reachable by the next 2 joints. Then solve the simpler 2D inverse kinematics problem. You will notice that there are 2 solutions. This is completely normal, as there may be multiple solutions to inverse kinematics problems, as the functions between the joint values and the positions is not bijective. The solution is made simpler using the cosine law. If the target is not reachable, the robot just gets as close as possible instead of giving up. The set of all reachable points is theoretically a hemisphere, but this is made smaller because a real robot cannot collide with itself. Orientation inverse kinematics. The orientation inverse kinematics problem is more complicated. The rotation of the end effector is a rotation from link 0 to 3 times the rotation from link 4 to 6. The following matrix equation must be solved for. It involves converting a rotation matrix into Euler ZXZ angles. Simulating a robotic arm is difficult. It requires 3D mechanics and applied geometry.